and welcome to my YouTube channel Infotech with Zafar Khan. Today I am going to discuss a new lecture for DevOps profile and it is lecture number 25. The agenda of this lecture is we will do a real-time DevOps project for provisioning resources using Terraform. In this project, we will create VPC, subnet, security group, internet gateway, NAT gateway, route table. We'll associate the route table and we'll create the elastic IP and of course EC2 instances. Very important video. Please watch the complete video for better understanding. As we are creating a number of resources, so you have to watch very carefully. If you get any confusion, watch it twice, thrice, and do the practice at your home so that you will get a more confidence. Just to remind you, creating a resources using Terraform is very easy and more interesting. We will not use AWS console and select the resources using GUI, graphic user interface, to create all resources. No, we will create everything through code. Don't bother about how to write the code, how to remember those codes. Writing code is very difficult. Then how to execute? No, nothing is panic. This is not a rocket science. You can do easily, that is for sure. Go to the official site of Terraform doc. Everything is mentioned over there. I will show you. Just need to copy and paste and change the code accordingly. I have provided the URL of the official document in the description section. So here is the scenario of the project. We will briefly discuss about the resources which I am going to use here. So first we will create the VPC. VPC means virtual private cloud. So it provides a logically isolated area of the AWS cloud where you can launch AWS resources in a virtual network that you define. You have complete control over the virtual networking environment, including a selection of your IP address range, the creation of subnets, configuration of route tables, and network gateway. We will have availability zone as well. Okay, so availability zone are distinct location within the AWS region that are engineered to be isolated from failures in other availability zones. If one availability zone is failure, the other will active and is working. They provide inexpensive, low latency network connectivity to other availability zone in the same AWS region. Low latency means fast response time. It means your response time is very fast. That is a low latency. We will create subnets as well. Okay, so we will create two subnets. One will be the private and the other will be the public subnet. So now what is subnet? A subnet is a range of IP addresses in your VPC. You can launch AWS resources such as EC2 instances into a specific subnet. For example, if you want to create a web server into public subnet, which can be accessible through internet, and database server into private subnet that cannot access through internet, which I am going to do in this project. One more thing, when you create a subnet, you specify the IPv4 CIDR block for the subnet, which is subset of VPC CIDR block. Each subnet must resides entirely within the availability zone. Then we will create a security group as well. Okay, so AWS security group acts as a virtual firewall for EC2 instances to control incoming and outgoing traffic. Both inbound and outbound rules control the flow of traffic to and from respectively. Then we will create the internet gateway. Okay, So now what is Internet Gateway? An Internet Gateway enables resources in your public subnet such as EC2 instance. So here in the web server basically to connect to the internet. So it allows the communication between your VPC and the internet. It supports IPv4 and IPv6. We will also create a route table for public subnet. So now what is route table? Route table basically contains a set of rules called routes that determines where network traffic from your subnet or gateway is directed. And then this route table we will associate it. Route table association is the association between the route table and the subnet and internet gateway or virtual private gateway. Then we will create the instance. Okay, so we will create the instance for web server under the public subnet and do the connectivity like SSH or all traffic. It can be accessed through internet via internet gateway. Then we will create an elastic IP. So now what is elastic IP? An elastic IP address is a static public IPv4 address associated with your AWS account in a specific region. Unlike an auto assigned public IP address, an elastic IP address is preserved after you stop and start your instance in a virtual private cloud. We'll create a database server. We will create the database server in a private subnet so that it cannot access through internet because there might be some critical data available in more which is more sensitive, not shareable. However, sometimes required to get access for database patching. So for this activity, we will create a NAT gateway in the public subnet. So we can access the database through NAT gateway. So now what is NAT gateway? A NAT gateway is a network address translation. You can use the NAT gateway so that in instance in a private subnet can connect to service outside your VPC, but external services cannot initiate a connection with those instances. And one more thing, just make a note. If both the servers are under the same VPC, then they can communicate with each other. Okay. Then we will create a route table for NAT gateway and we will associate it as well. So this is the steps, high level steps basically, which I have mentioned. We will create one by one. Okay. So let's start off creating a folder for our working directory and create files under this folder. First, I will make a folder for our working directory with the name Terraform project. So let's do that. Mkdir Terraform project hyphen project, right? Okay, go inside this project. This Terraform project. Cd Terraform project. So I'm going inside this folder. Okay. So now we don't have anything over here, right? So I will create two files. One is the provider.tf and the main.tf. Provider.tf I will select that. I will mention which provider I am going to use it, and then main.tf will be the number of resources over there, including security group as well. Okay, we can create a single file as well, but I want to keep the provider.tf in a separate one. Okay, so let's do that. Vi provider.tf. Okay, so let's go to the document. So this is the document which we will use it. Okay, so simply just copy, as I told, simply just copy this one and paste over here, right? So this one I will not do any change over here, but yes, this one need to be changed. Provider AWS, because we will use the US East Virginia. No, yeah, that's fine. We will use the North Virginia, so that's fine. But we have to include the access key as well as a secret key. Okay, so the access key is equal to, we have the access key probably here. Yes, this one is the access key which I have already generated, and then secret key, secret underscore key equal to, right? Yeah, so that's it. Yeah. So provider, we will do it. We will use AWS, and we are creating this uh, instances in the North Virginia. Oops, indentation should be correct. Yeah, that's fine. Yeah. Okay. So now this is one is the provider.tf we have completed. We'll create a main.tf. Main.tf. So this is the main file which I am going to create. We'll create all resources over here, including security group. Okay. So what we will do, first we will create a VPC. Okay. Just go over here and check where is the VPC. VPN, the VPC, virtual private cloud. Yeah. So virtual private cloud and AWS VPC. AWS VPC is here, right? So we will just copy this one and go to the terminal, paste over here. So VPC, you just change the name. You can change the name. VPC, AWS VPC, and then this is for reference one. So I will put info tech VPC. Infotech VPC. Okay, I will take a reference for this. I will use this as a reference. We can also put the tag as well. Okay, so here I'm just putting tags is equal to colon names is equal to, it will display here like this, info tech VPC. Once it is created, it will display in the console infotech VPC, right? So now we'll close this one, right? And we have closed this one. That's fine. So we have created VPC. Under this VPC, we will create a two subnet. One is the private subnet and the other one is the public subnet. Okay. So just now go to the document again. Okay. So now subnet AWS subnet, where it is. VPC subnet is a endpoint VPC. You can search also here subnets. So resources, AWS route, AWS database, AWS subnet. Resources under AWS subnet. Okay. So just click over here and copy this one. Simply copy from here and paste in the terminal. Okay. So now we will change the name as name. So public subnet we are creating first the public subnet. So put here the public subnet. Okay. And here the VPC ID. Under this VPC I am creating the VPC AWS VPC AWS VPC VPC dot infotech VPC dot ID. So infotech VPC dot ID. Yeah, and this is our CIDR block, right? And similarly here you change the name, tag name, public the public subnet, right? Yeah, similarly we will do for the private subnet. So just copying from here and paste over here and just change the name, private subnet, and we are creating under the same VPC AWS VPC, but the CIDR block should be changed. It's 2.0, and here we will write the private subnet. Yeah, so we have created the VPC and then the public subnet and private subnet. Yeah, so just save it. So two files we have. Okay, so let's execute this one first. So how you will execute, you know very well. Terraform init. First time it takes time because it is downloading. Okay, now Terraform clan. So three things we will create: VPC and two subnet, right? So everything is mentioned over here. This is our CIDR block for the private subnet. It is mentioned, and public subnet should CIDR block for the public subnet. Yeah, this is the public subnet and CIDR block I have mentioned. 10.0.1.0. Yeah, so now apply Terraform, apply. It will ask you, I will say yes, I want to perform this action. Yeah. So apply completed. This was a 3 added. No destroyed. No change. So just let me check whether it is created or not. So VPC, go to inside the VPC. Let's check VPC. Yeah. So Infotech VPC we have created, and it is showing the same CIDR block which I have mentioned. Okay. All details are mentioned over here. Okay. So first one is already created because it is a default VPC. It is mentioned over here, yes. But I have created this one. So it is not a default VPC I have created, and with the name Infotech VPC, right? So similarly, we'll go subnet as well. So some default subnet is already there, but we have created one private subnet and the other one is the public subnet. So under this Infotech VPC, okay, let's check Infotech VPC. So under this VPC, we have created two subnet, right? Okay. Now we will create a security group. So let's go to the terminal and create a security group as well. First, we will destroy this one. Okay. Terraform destroy. It will ask you to confirmation whether you want to destroy or not. So here I will put yes. I want to do that. Yeah, it is completed. So now under this VPC, we will create a security group. So just go to the document again and secure AWS security group. Search, you can search here. Security group, resources, security group. Okay, AWS security group, and copy this one as well. Very similar what we have done earlier. Copy the entire one and go to the vi main.tf. Yeah, so a lot of things that need to be changed over here. Security group, let's change this one. Infotech SG, small one, put the small one. Yeah, so description let it be same. So change this one, name Infotech SG. VPC main. So AWS VPC, what is the VPC name? Infotech VPC. Right, I have same reference number I have given, yeah. Infotech VPC. This one. Infotech VPC, yeah. Next one is ingress. Ingress rule means inbound. So its description, let it be, but here we will put the 22 port because we will do the SSH as well, and CIDR block we will put the main CIDR block. No, we will change this one. Okay, what we will do, put all. Okay, I am giving all, and this should be double quotes. And I am not using the IPv6, so I am removing this one. Okay, so what I will do, I will copy this one and one more ingress I will put over here. Why? Because I will use the internet, so that's why I need to change this one. Put it 0 anywhere. All, basically for all, and it would be from anywhere like this, all. Okay, and then this is a public one, that is also fine. Egress rule is also, let it be the same, but I am not going to use, as I said, IPv6 CIDR block I am not using, so I am removing this one as well. Yeah, and then the name which I will put, what was the name, that Infotech Security Group, Infotech SG. Info Security Group. Yeah, so let's save it. So security group also I have created. Okay, so again we can try Terraform plan. Now 4, this time 4, it will showing 4 because we are creating the security group, two subnets and one security group, so that's why. So let's apply this one, Terraform apply. Yes, oh sorry. So if you put anything wrong over there, it will say cancel. If you don't put or simply enter that one, it will apply cancel. So again, I have to apply. Yeah. So 4 things we have created. Let me check again. VPC we have already checked. Security group. So security group is also created. Okay, you can also check in the EC2 dashboard. So one security group is already there. Security group 2 is already there. 2 is default one. Okay, these are the default, and this one I have created Infotech security group. Okay, so these are the details of the security group. One SSH and all traffic which I have mentioned. As I told, one is 22 port and the other one 00 means all. Okay, and first one is a TCP, but I have put it over here all 0. Minus 1 basically, minus 1 also indicates all. So all traffic, okay, so which I have mentioned, so it is now created. Okay, next one is go to the terminal and we will create a internet gateway. Okay, just put vi main.tf. Okay, so create internet gateway. Go to that document and internet gateway. Under resources, internet gateway. VPC under resources, internet gateway. Okay, so just copy this one and paste in the terminal. So this is the internet gateway, AWS internet gateway. Similarly, I will change the name over here as well. I will put Infotech internet gateway. Infotech internet, IGW internet gateway. And here I am creating internet gateway in which VPC? Infotech VPC. Under this VPC, VPC ID, AWS VPC, and the name reference number, VPC, and then ID. You can add the tag as well. Info internet gateway, IGW. Okay. So once we have created the internet gateway, then we will create a route table because we have to associate the route table with this. So route table would be the public route table. Internet gateway generally used for public subnet. So we need to create a route table and that will be the public. Okay. So go to the document again and just check the route table. First internet gateway we have created. Internet attachment we will not put the route table. Route table under VPC AWS route table. Okay, so we will create this route table. We will not using this one, we will remove this one later. Okay, let's copy first and paste over here. So just remove this one. IPv6 we are not using, so that's why I'm removing. Okay, so give the name over here public route table. Okay, so public route table. VPC would be Infotech VPC. Infotech VPC. And the public CIDR block is because it is public, so I will put 0, and this one is also 0. Yeah, so 0 0. Okay, and the gateway ID AWS Internet Gateway. What is the name of the Internet Gateway? So AWS Internet Gateway, I'll remove this one and the reference number I'll put over here, info tech IGW, right? Okay, same name is over here, so that's why I have put it over here, same dot ID, and you can just put the public route, public route table. Okay, so similarly we will do the private route table as well, and we'll associate it. No, we'll not do the private route table. We'll create later when we will create an NAT gateway. So we will associate this one. Okay. So route table, public route table we have created, and we need to associate it. Okay. So just go to the document again and route table, AWS route table association. We'll click over here and just copy. So route table association, you can put the name over here, public route SO, public route SO, right? Okay, and under which subnet it will be? It will be public subnet, public subnet, and which table? Public route table. It need to be changed. Public RT means route table dot ID. Yeah. So we have created the public route and then public route SO. So before doing that, let's save it and we'll execute once again. Okay. So simply just put the apply one. Will not destroy anything over here. Okay. So just put the Terraform apply. It will refresh it first, the previous one, and then create the new one which I have written. Yeah, so refreshing. So three things it will add. Okay, the other one already created the three things. What the I mean internet gateway and then the route table and route table association. Okay, so just put yes. The three things added. So just go to the console and to the VPC. So subnet we have already seen, and then route table. We have created the route table, so public route table. Yeah. So this is our creation. The other one is the default route table. So but I have created this one. Okay. And then route table association. We have associate already. This is the VPC Infotech VPC, and this is the local one I have associated with the internet gateway. So, right? So it is associated now. So internet gateway, let's check. Internet gateway Infotech with IGW, and the name is this one. Details are there. VPC is also showing over here, right? So everything is now creating fine. So then we'll create a instance. Okay, web server first. Go to the main.tf. Okay, so let's create a web server first. Okay, so web server, go to the document, instance, AWS instance. AWS instance is under resource AWS instance, EC2 instance. Okay, no problem. We'll copy this one. Let's copy this one. Okay, paste over here, and we are creating the AWS instance. Let's put the web server. Web server. Okay, as we are using the US East one. Okay, this is just for commented. So AMI will select for the US East one. So how we will get it? Let's go to the AWS EC2 instance. Okay, launch. We will not launch it. We will just copy this one. Email. I mean AMI. AMI is this one for the Northern Virginia. Okay, and East we are using East one. US East one. Okay, so for this we have this AMI. So just copy this one and paste over here. Okay, and the T2 micro is fine. Then we have to put the key name as well. Key. So the key name is, I am using existing key name, Jen key. I have already created Jen key. Let me show you. Key pair. One key name is there, Jen key. So I am using the existing one. I have created earlier. Okay. So using the same Jen key. So that's why I have put it over here. Key name as Jen key. And the subnet ID, which under which subnet you are creating. Okay, so put the subnet ID, subnet underscore ID. So we are creating this one under subnet, AWS subnet dot. So as because it is a web server, so we will create public subnet, public hyphen subnet dot ID. Okay, and then we'll put the security group as well. So we have created already VPC underscore security underscore group underscore ID. So we are using the AWS security group, security group dot, the name of the security group, infotech SG dot ID. Yeah, so this is our web servers. Okay, so now we'll do the connection as well. So the connection we are doing type. What type of connection? Type is equal to SSH. Okay, host would be the self. dot public IP. I have already explained regarding this. Okay, user will be EC2 user. You know very well. Then private key. Here we'll mention the private key. Private underscore key. So we have generated the gen key. So just need to keep in the current directory. Okay, I will do that. What is the key name? Gen key dot pem. Connection we have completed now. Just put the tag as well. Tags is equal to name is equal to web server. Close the tag, and finally we'll close the web servers, right? So what we are doing over here, we'll creating the resource web server, and AMI I have put it over here. This is for the Northern Virginia. And instance type, we are taking the T2 micro. The key name, we are using the existing keys. The key name is Jenkins key. Subnet ID, under which subnet I am creating, in the public subnet. So that's why AWS subnet dot public subnet ID. And then we also associate with the security group, that is our AWS security group name is infotech sg dot id, and we will we will do the SSH 22 port I have given, so that's why SSH. Host is a self public IP, and then user will we will use the EC2 user. Private key is the PAM file basically. So that's why I have mentioned the file over here, and will execute in the current directory, working directory which I have created. So I need to copy this PAM file from our desktop to working directory. Okay, so this is what we have created. So let's save it and just go back and check. Keygen PAM file is there, so we'll copy this one to our Terraform project. Okay, so copy gen key dot pm, where Terraform project. Let's go to inside that and check everything is there or not. Yes, so we have provider.tf that we have already created earlier, and the main.tf which we are creating, and then PAM file also. But this is read write executable permission, which is not good, so we have to change the permission. So ch mode, put the 400 gen key dot pem. Check, so only read permission is there, right? Okay, so now we'll destroy first and then we'll create the EC2 instance. Okay, Terraform destroy. Oh, yes, here I did mistake, right? Okay, Terraform plan, VPC security group IDs. What I have written, ID? No, it should be IDs. Yes. So this is also fine because we are also learning over here. Okay, so here it should be IDs rather than ID. So we also tracking the errors also. So that would be fine for everyone. So make sure you are doing correctly. Okay, It's a human error. Terraform plan. Previous one is the refreshing, and then one plan, one EC2 instance. So put Terraform apply. Terraform apply. Yes, so we have created the EC2 instance as well. So let's check, but I think IP address will not show over here. So let's check now. Okay. Yeah. So private IP is generated, but IP address is not showing over here. So we need to do the elastic IP over here. Okay, so let's create a first. Let complete it first because it is initializing. Yeah. So it is now running. So we don't have any IP. Okay, so let me do the IP as well. So what I will do, I will create an EIP, elastic IP. Okay, go to the vi.tf. Okay, okay. So we'll create the EIP. Okay, so just go here, and if you have any issue, then just EIP, AWS EIP resources. Let's copy this one and paste over here. Put the name Infotech AWS ID. Infotech EIP. AWS instance. So web server name which I have given, and VPC true. Okay. So now save it and apply. Yes, so one is applied now. Okay, so go to the EC2 instance and check EIP is there or not. So now it is created. So public IP4 address, this is the public IP. Okay, so we have created internet gateway, we have created the public subnet and private subnet as well. We have created the web server also, and have attached this IP address to web server. So let's check whether we are able to connect or not. Okay, so what I will do, I will do SSH hyphen I and then keygen. Sorry, what was the key name? Gen key dot pm, right? EC2 user at the rate of, it should connect. Yes, so we are able to connect now with this IP, and we are let me check whether we are able to Ping the google.com. So just ping google.com. Yes, so it is now connected. Control C. So now we are able to connect the web server through internet gateway. Okay, so this is the indication that we are able to ping. Okay, google.com. And if you want to install, so you can install as well. So sudo, just a small thing, we will install it. Scu yum install git. Yeah, we are able to, no issue. Yes, so we are able to do everything, right? So just exit now and exit from here as well, right? So now we will create the database server. Okay, but we will not attach the EIP in this database server, because directly from internet we cannot access to the database server, because some sensitive data is there, which I have already discussed. Okay, so we'll create a database server as well. Go to main.tf file. Now what we will do, we will copy everything. Yeah, so we will copy this everything over from here and just paste and put the name db server. It is same T2 micro, so we are using the same key, but here we will use the private subnet. So we have not created the private subnet, but we'll create private subnet. Okay, and security ID, yes, it is the same security ID. And this one host name is not required, you can hash out it. Okay, it's the same key here as well, and the name we change database server. Database server. EIP will create but will not associate it. So just remove this one. So what I will do, I will remove this one. Infotech AWS EIP. No, Infotech AWS, we will use the NAT gateway. NAT gateway ID. NAT gateway ID. We'll create the NAT gateway. AWS NAT gateway. We'll keep the name AWS NAT gateway. Infotech AWS NAT gateway ID. Yeah. Oh, that's fine. Then we'll create the NAT gateway as well. So let's create a NAT gateway. Document. And this VPC AWS NAT gateway. Internet gateway, NAT gateway. Okay. So just copy this one. Paste over here. And NAT gateway name. Infotech AWS NG ID. Full name we have to give the same name. Data we copy from here and paste. Okay, and allocation ID, NAT gateway we are creating in the public subnet, right? In the public subnet, you remember it, public subnet, public hyphen subnet, AWS subnet, public subnet, under public subnet, NAT gateway. tag name you just put the NAT gateway. Okay, private subnet also created. Then what we will do, we'll do the private route table. We'll create a private route table. This NAT gateway we have created in the public subnet. Let me create the route table, private route table. So private route table. This is the route table. We'll copy the same things. We'll remove this one. Okay. So CIDR block will keep 0, 0. Private route table, and then VPC, you know very well, Infotech VPC. VPC gateway ID, AWS Internet Gateway. No, AWS NAT Gateway. It will be AWS NAT Gateway. And what is the ID reference? Through NAT Gateway, we will use it. Okay, so AWS NGW. Is it the same name? Do one thing, this long name is there, so AWS NGW, just put it over here rather than the big name. AWS NG ID over here, right? And then put the tag name is equal to private route table. Private route table. So we have created now NAT gateway and the private route table. We'll associate it as well. Route table association. Put the name private route SO. Private route SO, and then it will be in the private subnet, AWS subnet, private subnet, associate with the private subnet, but we have created in the public subnet. Route table, NAT gateway we have created in the public subnet, and then route table we have created, and this route table is associated with the private subnet, and route table ID which we have already created. So route table ID would be AWS route table dot AWS route table private route table private RT dot ID. Yeah. So I think I have completed. So let's save it. Oh no. Yes. So now what we will do, we'll destroy everything and then apply again. Okay. So first Terraform destroy unclosed. Something is wrong. Go to the main.tf. Something is not closed. Probably I have copied something. Okay, I guess no, web server is closed. database server is also closed. This one is also closed. Yeah, NAT Gateway is not closed yet. Now it is closed. And route table, private route table is closed. This one is also closed. This one is also closed. That's fine now. Destroy now. Yes. When you apply it, it will be take little bit time because NAT gateway will take time to create. So let's destroy it first, then we will apply. Okay, so 9 is destroyed and let's apply Terraform. Apply. Probably it would be 14. 14, yes, it is showing the 14 plan. So yes. Okay, no issue. Okay, one thing we need to add over here, that is allocation ID. Allocation ID underscore ID. Right, so AWS underscore EIP dot infotech AWS NGWID NAT gateway dot ID. Yes, this is also required. So AWS EIP infotech AWS NGID. Yeah, so this one was missing, so that's why getting error. So let's apply, check. Perfect. So now we have created. Okay, resolve the issues. We will destroy first for everything and we'll create a fresh one basically. So let's destroy first. Terraform destroy. Yes. It's destroying everything. still destroying the database servers because this one is under NAT Gateway, so that's why it's taking time. For NAT Gateway, generally it's take time. Yeah. So now 14 resources has been destroyed. Okay. So let's apply now. Terraform apply. We don't have anything running over here. There is no instance. So zero running. So now we have applied, it will create everything. So I'll put over here, yes, perform these actions. Yeah. So it's applied now for all 14 resources. So let's check what are the instances that is running. So here it's still initializing. So let it complete. Okay, so this is the public IP, elastic IP basically, which I have created. Okay, so we will do SSH connectivity, SSH hyphen I, then chain key dot pim EC2 user at the rate of elastic IP. Once it is created, then we'll connect. Still initializing. Yes, so now web server is completed. So web server and database both are completed. So let's connect it now. Yes. Okay, so we are able to connect the web server. So I want to just ping the web server whether we are able to connect through internet. Google.com. Yeah, we are able to ping this server, but we cannot connect with the database server. So what we will do, we will connect from here. But for this connection, we require the gen key in this server so that it will connect from this server to database server. Okay. So what I will do, I will exit from here. Okay. So connection closed now. So we have gen key pim file over here. So what we will do, we'll copy from here gen key dot pim. What I am doing, please watch carefully. It's a very big project, okay, and in the industry, definitely you will going to be used. Control C, and just go to connect again this server. Okay, and vi with the same name, gen key dot pim. Okay, and paste over here this key and just save it. Okay, so you can see one file over here, gen pem file, but it is a read write permission, so we will change the permission mode. So ch mode 400 gen key dot pm. Okay, so I'll check once again. So it is readable only. So from this server, let's check whether we are able to connect with the database server. So ssh-i gen key dot pm EC2 user, at the rate of private IP, because there is no public IP for the database server. So it's a private IP. Yes. Yeah. So we are now connected with the database server as well. And let's try to ping from here. Ping google.com. Yeah. So now we are able to connect. So database server through internet we cannot connect. So we can connect through the NAT gateway. Okay, so we have everything we have completed over here. So through Terraform, you may able to launch the application process involving a VPC, subnets, API gateway like internet gateway, NAT gateway, which integrate with the various AWS services. Okay, so thank you. We will meet again with the new project. Thanks for watching. If you like this video, don't forget to click the subscribe button please.